Okay, so we are starting section 4.7 now, equivalent formulas. You'll be taking your own notes again. Make sure you do copy down everything, including the directions to the examples I give you, so that way you'll recognize those directions and what you're actually doing later. So we're going to be solving an equation for one of the variables in a given equation. So it's exactly what we've been doing where we're trying to isolate a variable and solve for a variable. It's just now we may have more than one variable in the equation, but we're still going to focus on isolating one of those variables. So why do this? One reason, this is just a very common example, is we have common temperature scales. We have degrees Celsius and we have degrees Fahrenheit. Well, we're one of the only places that actually uses Fahrenheit. Most other countries use Celsius. So we have different formulas that we can use, but they are equivalent. So, for example, on the temperature scale, freezing water in degrees Celsius would be 0 degrees Celsius. That's when water is going to freeze, but it's going to boil at 100 degrees Celsius. But the conversion to the Fahrenheit equation, we have 32 degrees for the freezing water temperature, and then 212 degrees Fahrenheit for when water boils. So we're able to use this or solve for one of the variables to convert from degrees Celsius or degrees Fahrenheit or vice versa. So a lot of times we can isolate one variable to convert to use it in another way, or to help us solve something a little bit quicker and a little bit easier. So let's just first look at our formula for Fahrenheit. We want to solve for C, so we want to convert this such that we solve for C, so degrees Celsius. So what that means is, if we're solving for C, we're still just isolating C. We're trying to get it all by itself. So we still do everything exactly like we always have. So for example, I'm going to subtract 32 from both sides. So I end up with F minus 32 equals 9/5 C. Well, what do we do to get rid of the 9/5? We need this to be a 1C, so we can multiply by the reciprocal. Any number multiplied by its reciprocal gives us 1. Make sure you are multiplying this entire side by 5/9. So we want to make sure that we include the parentheses to show that we're multiplying by both the F and the negative 32. So we're left with 5/9 times the point of F minus 32 equals C. So to find the degrees Celsius, let's say we said it's 60 degrees Fahrenheit out. So now I can see what is that in degrees Celsius by plugging in 60 for F and then simplifying that tells me what it is in degrees Celsius. So for example, what we're going to look at here in a second, if I go back up to this table, if I say the degrees Celsius is 0, the Fahrenheit should be 32 or vice versa. If I say it's 32 degrees Fahrenheit outside, that would convert to 0 degrees Celsius, same thing with boiling. If water's boiling at 212 degrees Fahrenheit, that means that it would be converted to 100 degrees Celsius. And how do we convert? We can use these formulas that we have here. So, we ended up with, let me just write down again what we had here. We ended up with 5/9 times F minus 32 equals C. These are equivalent formulas. So what do I mean by that? That means if I were to plug in, let's say, 212 for F, I should get out 100. Or if I were to plug in 100 for C, here I should get out 212. So let's see if that happens. That means that they would be equivalent formulas. If I get what I plug in for one is what I get out for the other. So every value that would satisfy one equation satisfies the other. So for example, this equation here is F in terms of C. So this is an equation for F in terms of C, meaning C is my input, F is my output. This is an equation for C in terms of F. So again, F is now my input, and C is my output. So let's see what happens if I plug in let's see what happens if I plug in 100 for C. What should I get out? I should get out 212 because when C is 100, the Fahrenheit, what it converts to is 212. So let's make sure that that happens. So what I want you to do is figure out what F equals. See what you get. Now this one, let's look at the input. Let's say we plug in when does water boil for Fahrenheit? 212. So let's plug in 212 and see what we get for degrees Celsius. So what should we get for degrees Celsius? We should get 100. What should we get for degrees Fahrenheit? We should get 212. So I want you to double check that. So if my Fahrenheit is 212, C should be 100. If my degrees Celsius is 100, F should be 212. So if we get that, so that's what you are going to check. If we get that, that means we have equivalent formulas. Because every value of F and C that satisfies the equation satisfies the other equation as well. So if I plug in 1 for C, I go to the other equation, it satisfies that other equation or makes the other equation true as well. So let's look at a couple more examples of solving for a given variable. So we have x equals 2y minus 3, and we want to solve for y. So we want to isolate y, get y by itself. So just like we've always done, we're going to work to get that value by itself. So now I have x plus 3 equals 2y, that's 0. Now what do I do to get y by itself? I divide by 2. Make sure you divide the entire side by 2. So x plus 3 divided by 2 equals y. So I'm not getting a value, I'm just rearranging it such that, okay, now let's say I wanted x to be my input, I can plug in a number for x and figure out what y is rather quickly. So that's how you do that one. So it's nothing new, it's just we're working with more variables now and not just numbers. We're not getting an actual number value. So the next one, c equals 2 pi r. We want to solve for r, so we want to get r by itself. Well, pi is a value, we usually say it's approximately 3.14. But realize this is all smashed together, so this is 2 times pi times r. Well, how do I undo multiplication? If these are all being multiplied, can't I just divide? So if I divide this side by 2 pi, and this side by 2 pi, 2 pi divided by 2 pi is just 1. So c divided by 2 pi is what r equals. Again, I've isolated r, so now let's say I need the circumference of a circle. I take the circumference divided by 2 pi, and now I know the radius. Just can help me in solving based upon given information I have. And you'll see this a lot, especially when we get into talking about linear systems. Okay, v equals x over t, or x divided by t, and I want to solve for t. Well, let's look where t is. T is in the denominator, it's x divided by t. So, if I want to get t by itself, the first thing I need to do is to multiply both sides by t. I need to get it to the numerator. So, doing so, I have t times v, or tv, equals x. So what do I do to get t by itself? Divide both sides by v, because it was t times v. So t equals x divided by v. Again, all the same steps as we've always used. We are just isolating one variable, getting it by itself, not getting a value, still getting another expression. Last one. PV equals nRT, or n times r times t, and we want to solve for t. We want to get t all by itself. So it's all multiplication, so what do? I can just go ahead and divide in one step. nr divided by nr is 1. Anything divided by itself is always 1. So PV over nr equals t. That is my equation for t. And we'll work with this with area formulas, circumference formulas. You'll be seeing that a lot. So what I want you to do for homework then, I want you to solve for the stated variable. So you have these two questions to do. I will check them in class tomorrow. We'll go over them, and I will see you then.